Okay. So this is more 3D printer stuff. Um, this is a gigantic LED panel. Those are adafruit 32 by 32 panels, 6 of them. I have photos of this. This is being done on the chip kit. It's reflective. There's acrylic mounted on it. But the thing I really wanted to discuss was these pieces I printed to hold all of this together. So all of this is in blue glow in the dark PLA because that was the color that it happened to be glow in the dark, but I wanted the color more than anything. So you can see that Adafruit stuff was, as they shipped it, it was too high profile. So I unsoldered all of the power connectors, and this is kind of the idea here. There's a lot of, get the other side. There we go. There's a lot of this sort of thing going on where in the model, again, it was all print. This was the face in contact with the print bed because support structure. There we go. There's some focus. I used a rectangle here, a rectangular prism. I don't know, but I don't know what to call it. In Blender, if you Shift A, add a mesh, add a cube, and then you stretch it to fit your dimensions, then you do a Boolean difference with the part that you're interested in, and then you get this little cutout channel. These are just plastic savers. Plus, they look kind of cool. But those are all just you start with one cylinder. You create a cylinder that has 6 vertices. I'm sick of holding this. I'm going to put this up here. There we go. So you start with a cylinder that has 6 vertices, and you end up with a cylinder. Well, it's a hexagon, but it's extruded into a cylinder. Then you use in Blender. I'm using Blender as a CAD package. If you haven't gathered that by now, I don't know how to do the animation stuff with it, and I don't know another CAD package other than KiCad. So Blender's my go-to. But in the in the modifiers pane in object mode, you can add a modifier called array, and you take that one cylinder and add the array modifier to it, and you can build these arrays without having to replicate your geometry everywhere, which is really useful if you decide you want to resize that one piece and have all of the others resize and scale to fit appropriately. And it's just done automatically because it's generated. So there's a few basic pieces here. This was now I do have to pick it up. All right. So this piece, this piece, this piece, the mirror images of those, and then in the center, this piece and this piece up here, all overhang, and they all come down past the boundary of the panel. So this is the simple piece. You can see that so the way to do this in Blender is to get if you don't have a micrometer and you're doing this sort of work, spend the $10 and get one because it'll save you enormous amounts of pain. But use the micrometer, measure out the panel, figure out what its height is. And again, my printer has a tolerance of 0.4 millimeter on the print. But you can see that I just, it wasn't critical on these pieces, so I didn't model it too exactly because there's an air gap there. But you can see that on this piece it was pretty critical. So and that focus isn't going to come out, unfortunately. But you can see that there's almost no difference in the height between the bottom of this piece, like the bottom of this area, and then the bottom of this one versus the panel. So to do that sort of thing in Blender, you just, again, Shift A, add a cube, stretch it to your dimensions, and it's useful to apply the scale after you do that so that you don't have measurement issues later on. Usually you don't run into that sort of thing, but I just do it out of habit. I'll take some screen video later of me modeling something like this, but for now I'm just showing the results. After you get your parts modeled, you then, at least this is how I did it, is in my Blender file I have all of these brackets laid out just like this. So it looks just like this in Blender, and it has the panel being there. I can then do Boolean differences on each individual piece and it will, or in some cases, the arrays of pieces, and it will take the panel out for you automatically. And you can just change things around later, and you don't have to worry about changing the geometry that you earlier committed to because you had to subtract for the panel, which is usually my first step. There's usually one piece in a project that is, defines the shape and scale of everything else. In this case, it's this panel. But a couple of words about these, because these things are evil. This distance is not the same as this distance. And I had to go through a couple of junk pieces, which are over here in this box. These are actually not junk, but these are all junk pieces because I printed a bunch of them up without test fitting them. So that was my fault. In this case, I decided to change I think I liked the border, so I threw that one away for a different reason. But, oh, there we go. Yep. So this is the piece. This is the piece that, I don't know who designed these panels, but that distance is wrong. That distance is also wrong. Where was the correct distance? That was the correct dimension. I don't know who designed these panels, but is it really too much to ask to make stuff like that equal dimension? It would make everyone's life a lot easier. But it is what it is, and it got done. So on the bottom side of that, though, you see that there's another one of those hexagonal insets, and that's for press fitting a nut. So you can see that I've done that on this particular piece. The screws are all countersunk so that I can get a lower profile. It's effortless to countersink screws like that, and it adds so much value, both depending aesthetically, but also because of the fact that you save plastic and you keep your profiles low. Over here, so there's this one similar to this cutout strategy over here that you see on the left with the ribbon cable. I did another cutout strategy. Oh, don't want to interfere with my light. Maybe this side. So I did a similar cutout strategy for the wire that I was intending on using. So that's just 4 cylinders that again arrayed. Just create the cylinder of the proper dimension, run it through your piece, and in this model's case, I ran it vertically all the way through, so that every piece that, like this piece ran, it was one single set of cylinders that ran through, and I just did subtractions on both. And by doing it that way, you ensure that they're not offset in some strange way that you have to deal with later. So these are the 3 cables that are coming out of the thing. Each one of these is there's the other one, are going to be independently driven. So 3 chains of 2 deep. So this is all going to get put together, finished with this power supply. This is a 200 watt 5 volt power supply that was presumably made for driving LEDs, but it'll do the job. So I have to get some instruction from Microchip about how they want to handle the mounting of this thing, and then I can complete the back. So I envisioned that this whole assembly would be sandwiched between 2 acrylic or polycarbonate plates. I chose acrylic because of the cost. It's a little more difficult to work, but I had 2 of these sheets, and I was cutting the stuff as a challenge. Had some attrition, so I'm going to have to go pick up another acrylic sheet if that's what they want. But it might also be a VESA mount, in which case I'll probably do aluminum. But yeah, so that's that panel. Came out pretty well. I'll get back when I have more of it assembled.